Good afternoon, folks. So this is the 2014 ordinary level geologic geometry question. It's in the applied graphics section, the section C of the paper. Okay. So question C1, it says the accompanying map located on the back page of section A shows ground contours at 5 meter vertical intervals. So that's something to be aware of. Okay. Part A, on the map on the drawing supplied, draw a vertical section profile on the line AB. So that's our first thing we have to do. Then part B, C, D and E are outcrop points on the surface of a stratum of ore. Determine the strike and dip of that stratum. Okay, so strike and dip is what we have to get there. So for part A, first of all, it says we have to get a vertical section profile along the line AB. So we've done this a few times now. So what we're going to do first of all is using our scale. So our scale on the sheet, our scale given to us is 1 millimeter on our sheet. OS is to 1000 millimeters in reality. Now the distance between our contours, we can see here 50 to 55 is 5 meters, and they tell us it up here as well. So what do I have to multiply this by to make 5 meters? Well, 1000 millimeters equates to 1 meter, so I have to multiply it by 5. So if I multiply this by 5, that's going to be 5000 millimeters, which is 5 meters. I also have to multiply this by 5. Therefore, 5 is kind of my magic number. 5 millimeters on my sheet equates to 5000 millimeters in reality. Okay, so that's what we're going to use to help us do our vertical section profile. Okay, so we'll start with that there now. So what I'd like to do here is from B, I'm going to put in my measurements going up here like this, and just looking along the line, I'm going to find the highest and the lowest. So the highest seems to be 65 and the lowest seems to be, just looking along the line there, I think it's 35. Okay, and the highest is 65 and the lowest seems to be 35. Therefore I'm going to use this line here, okay, kind of like my XY line. I'm going to call that one 30. Okay, I'm going to call that one, just making sure, yeah, 30. Alright, so with that being 30, I'm going to measure up in 5 millimeter increments from there. Just make sure we're measured accurately now. So 30, 35, 40, 45, 50, 55, 60, 65. So I'm going to plot in my contour heights. Okay, I'll write them in at the side. So if this is 30, 35, 40, 45, 50, 55, 60, and finally 65. So now it's a case of where the vertical line, okay, or sorry, the vertical section profile, okay, is cutting through my contours. That will reveal the topography of the land, okay, basically kind of the shape the land is making if we were to slice through it. So at the A one here, I can see that is actually on a 35 contour. If I follow it down, so that comes up to here, and so on. And just repeat the process. Everywhere the contour passes through the profile AB, I project it up. So this one's at 40. Then the next one's at 45. Next one's at 50. Then we have 55. Then I have 60. Then I have 65. And followed around, you can see, look, it's 65, but it's 65 again here. Before we go back down to 60. Then we have 55. Then 50. Just make sure I'm at the right height, yeah, no mistakes. 45, 40, 35. So 35 here, I have another 35 over here, 40 again, and finally a 45. So what I like to do is just identify those marks. Just so it kind of shows to me. The profile of the land. And the last one was 45, so you can kind of see the profile of the land is taken there, so I'll quickly sketch that in. So there we have it, guys. That is the vertical section profile done along the line AB. Okay, where I'll identify A as well actually. And there's B over here. So part A of that question is done. Okay, now what we're going on to is part B. So C, D and E are outcrop points on the surface of a stratum of ore. Okay, so basically if you take ore like a gold sample, okay, or something we're looking for in the ground, what we have to do is we determine the strike and the dip of that stratum. Okay, so the dip first of all is the angle that makes in relation to the horizontal plane, essentially a flat surface, the ground. Okay, the strike is the level line that runs along that surface. Okay, and the strike is going to help us get the dip. So we have to get the strike first. So first of all, we'll find C, D and E, and I can see them here. Okay, they're in our plan view down here, and if we're taking this up section up here as our elevation, where I'm treating this guy almost like an XY line there. It's not really, I suppose, but I'm going to treat it like it is. Okay, so I'm going to connect C to D to E and make a plane surface, a plane triangular surface. And if I have them in plan, I also have to find them in my elevation views. Okay, so it's going to be up here. So I can look at what heights the contours are on. Okay, so starting with C, if I follow it over, I can see C is at the 35 height. So C is up there. E then is at the 45. I want to make sure I have the right ones. And then D, if I follow it down, D is on the 60. Okay, just making sure that. So follow it over here. Yeah, D is on the 60. Okay, so I want to identify those. So there's D, C and E. So connect those up in my elevation view. And that is what the triangle looks like in my elevation view. Now what we want to do is we want to find the strike. So the strike is a level line, but it's actually a true length that we need to find. So the best way to do that is we want to go parallel to one of the principal planes of reference, either the vertical plane or the horizontal plane. Now I told you earlier that we're going to treat this line like the XY line. So if we take that as our horizontal plane, okay? So what I'm actually going to do is from E, which is the middle one, okay, of these three heights, C is the lowest, D is the highest, E. From my E position here, I'm going to project across a level line, like that, to cut my line CD right here. Where that cuts it, in my elevation, I'm going to project that point down to my plan. And it gives me a point here. Like I've connected it in elevation there, I'm also going to connect it up to E in my plan. And that line there is my strike line. So that's the first thing we found. That strike is a true length. Okay, I'm going to write in strike equals true length. Okay, the strike is our true length. Now, if we look along that line, the strike line, okay, when we look along a true length, we will see it as a point view. Okay, when we look along a true length, if we look along a line, okay, we'll see it as a point view. Okay, and because that strike line is a true length and it's sitting on this surface CDE, we will therefore see the surface CDE as an edge view. So we're going to actually use a bit of an auxiliary view here. Okay, so we're going to look along the strike line. We're going to project out. Going to rotate perpendicular to set up an auxiliary view. Which is known as an X1, Y1. And I'm going to project out all of my points. So that's the C1, E is out there as well, and D is actually the highest one. It's probably that's the one I need to bring the highest, not this one. Okay, so here's my X1, Y1. I'm going to treat this X1, Y1 that it's at a height of, once again, same as up here. I'm going to go with 30. Okay, so what we're going to do is we're going to take the heights from up here. Now we know C, okay, from the XY line as we were treating it is up 5 millimeters. So for C down here, project from plan, take your heights from the elevation. Going to measure up a distance of 5. So that point right there is C1. Now for E, going to take the height like this. Look, I could add it, it's 15. I'll just use my compass in this case and step it out from here. Okay, and then finally for D, 5, 10, 15, it should be 30. I'll just mark it, just to have it exact. Find D, come out to my X and Y1. As always, so labeling is very important, indexing, D1. All of these should meet in a line, and I can see they do. Okay, and what we're essentially seeing is this triangular surface as an edge view. Okay, so that there is an edge view of C, D, E, okay, where E here, E1, okay, is a point view of our strike, okay. But what's important here is, and we have the answer got, the angle inside in here, that angle in there is our dip, okay, and you could measure it with a protractor there, okay. So there we have it. We have now found the dip and strike of the stratum, okay. So I hope you found that helpful, guys. That was 2014 ordinary level geologic geometry question.